Okay, so now that we've simplified square roots, we're going to go ahead and talk about division. And we're going to talk about fractions. And fractions are really just a special way of dividing. And our problem with fractions is that we can't have a square root at the bottom. So what happens if we have a square root on the bottom? We're going to do a process called rationalizing the denominator. So when performing operations with fractions that have radicals in them, it's easier to have the radical in the top of the fraction, the numerator. When the radical is in the denominator, which is the bottom of the fraction, we move it to the top by using a process called rationalizing the denominator. To rationalize the denominator, we're going to give our fraction a makeover. This means that we aren't going to change its original value, we're going to change its look. So very similar to saying that 1/2 is the same thing as 0.5, which is the same thing as 2/4, which is the same thing as 5/10. They're all the exact same value, just different looks to them. And so what we're going to do is we're going to take our fraction and we're going to give it a new look. We're going to give it a makeover. And we're going to do that by multiplying our fraction by a version of 1. And so really, since anything divided by itself is 1, like 2/2 is 1, 3/3 is 1, well, the square root of 2 over the square root of 2 is also 1, and the square root of 3 over the square root of 3 is also 1. And we're going to use that idea to multiply our fraction by the radical we are trying to move. So for example, if I have the problem of 1 over the square root of 3, I cannot have that square root of 3 in the bottom. Since I want to move the square root of 3, I'm going to times by 1. But my 1's going to look like the square root of 3 over the square root of 3, because the square root of 3 is what I want to move. So my 1's going to look like what I want to move over what I want to move. So this is really just the magical number 1. But I don't want it to be 1 because I don't want it to look exactly the same. I'm going to give it a makeover. So when I do this, I'm now going to go ahead and I'm going to multiply across the top. So 1 times the square root of 3 gives me square root of 3. Now I'm going to multiply the bottom. The square root of 3 times the square root of 3 is really the square root of 9. Now, luckily, we notice that the square root of 9 is really the number 3. And so now we get a brand new fraction that does not have the square root on the bottom. Why is that important? Because if we have to add and subtract fractions, we have to have a common denominator, and it's easier to have a denominator that is a number like 3 than the square root of 3. So that's the purpose behind this. So we're going to go ahead and practice. So our first problem is 1 over the square root of 2. Well, what do I want to get rid of? I want to get rid of the square root of 2, so I'm going to take my original fraction, and I'm going to times by what I want to get rid of. I want to get rid of the square root of 2. And so what's this going to give me? Well, I multiply across the top, so 1 times square root of 2 is square root of 2. And then on the bottom, square root of 2 times square root of 2 is square root of 4. What is the square root of 4? It's 2. So this is the square root of 2 over 2. Now the other question I get is, why don't those 2's cancel out? And that's because it's not a 2 and a 2, it's really square root of 2. And if we take our calculators, the square root of 2 is really 1.4. So this is like a 1.4 blah, 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 blah over 2. And that can't cancel because they're not the same value. And so those 2's can't cancel unless they're exactly the same. And they're not, because 1 has a square root with it. Okay, so our next one, 1 over the square root of 5. So I want to get rid of the square root of 5 on bottom. So I'm going to take my 1 over the square root of 5. And I'm going to times by the square root of 5 over square root of 5. So then I times across the top, and I get 1 square root of 5. But remember that 1 can really be invisible. And the bottom, square root of 5 times square root of 5 is square root of 25. Well, what is the square root of 25? It's just 5. So this is really square root of 5 over 5. Okay, next one, 7 over the square root of 2. So I want to get rid of the square root of 2. So that's what I'm going to times by. Square root of 2 over square root of 2. Now when I times across the top, 7 times the square root of 2 is just 7 square roots of 2. Because they're not both underneath the square root, I can't combine them in any way, so they just kind of become roommates chilling there together. And on the bottom, square root of 2 times square root of 2 is square root of 4. And what is the square root of 4? It's just 2. So this is 7 square root of 2 over 2. And that's our answer. So our next one, 7 over the square root of 5. So I want to get rid of the square root of 5. So I times by square root of 5 over square root of 5. So then on the top I get 7 square roots of 5. Again, I can't combine them because one's a square root and one isn't. And on the bottom, square root of 5 times square root of 5 is square root of 25. Now we should know that the square root of 25 is really 5. So this is 7 square roots of 5 over 5. Now the last thing I do want to address is what happens if I end up with something like, 8 square roots of 2 over 2. Am I really done with that? No, because these are regular numbers, and these regular numbers can simplify. So what is 8 divided by 2? Well, that's 4, so this would become 4 square roots of 2. And so then that becomes even more simplified. So even though these fractions here, 7 over 2, don't simplify, and 7 over 5 doesn't simplify, if they can simplify, it is your responsibility to simplify them.